Ever wondered how your computer actually talks to the internet? It all happens through protocols, the agreed-upon rules that let devices, servers, and networks exchange information without chaos. They run as software instructions on your operating system, routers, and servers, quietly making sure data knows where to go and how to get there. HTTP and HTTPS. HTTP is the protocol your browser uses to request and load websites. When you type something into the address bar, your browser sends an HTTP request as a packet to the server. HTTPS is the secure version. It encrypts that packet, so only the site you're talking to can read it. TCP, Transmission Control Protocol. It runs on your computer, servers, and routers. It makes sure data packets arrive reliably and in the correct order. Think of it like a delivery driver who checks every box off the list. If a packet goes missing, TCP asks for it again. IP, Internet Protocol. It works alongside TCP and handles addressing, putting the to and from labels on every packet, so routers and networks know where to send it. IP is what makes sure your data doesn't just float around randomly, but actually reaches the right destination. Together, they form TCP/IP. It's built into every operating system, router, and ISP system, the universal language of the internet. Whether you're streaming video, sending an email, or loading a website, TCP/IP is the backbone moving that data reliably from one machine to another. UDP, User Datagram Protocol. It's like TCP without the seatbelt. It skips error checking to send data faster, which makes it great for video calls, games, and streams where speed matters more than perfection. DNS, Domain Name System. It translates domain names like example.com into IP addresses so your computer knows where to connect. It's the internet's address book, and if attackers tamper with it, you can be redirected to fake sites. FTP, File Transfer Protocol. It was one of the earliest ways to move files between computers, but it's insecure because everything is sent in plain text. To fix this, two secure versions appeared. FTPS, which adds SSL and TLS encryption, and SFTP, which actually runs over SSH. Most developers and sysadmins rarely use plain FTP. Instead, they rely on SFTP, or skip it entirely in favor of SSH-based tools like SCP and rsync to upload code, move backups, or manage servers. SSH, Secure Shell. It's the backbone of modern server management. It lets system administrators and developers log into remote machines securely, run commands, configure software, and transfer files, all with encryption protecting every keystroke and file. SSH replaced old, insecure methods like Telnet and FTP, and today it's the standard way to manage websites, cloud servers, and even IoT devices. Without SSH, modern DevOps and cloud computing wouldn't really function. SMTP, Simple Mail Transfer Protocol. It's what sends your emails out, used by mail servers to deliver messages. POP3 and IMAP handle incoming mail. POP3 downloads emails to one device, while IMAP keeps them synced across devices. Basically, whenever you use Gmail, Outlook, or any mail app, these protocols are working behind the scenes. ICMP, Internet Control Message Protocol. It powers the ping command. It runs at the network layer, inside routers and operating systems, to test connectivity and report errors. Great for troubleshooting. But attackers also use it to map out networks. ARP, Address Resolution Protocol. It matches IP addresses to physical MAC addresses, so devices on a local network know where to send packets. It lives inside your local router and every device's network stack. Without ARP, your computer wouldn't know how to talk to other machines on the same LAN. But attackers can spoof ARP replies to hijack traffic. That's called ARP poisoning. DHCP, Dynamic Host Configuration Protocol. It's what gives your devices an IP address automatically when they connect. It usually runs on your home router or a dedicated server in larger networks. Without it, you'd have to manually configure the IP settings on every single device. Attackers can exploit rogue DHCP servers to reroute traffic through them. SSL and TLS. They're the protocols that secure web traffic. When you see that little padlock in your browser, it means TLS is encrypting your connection so nobody can read or tamper with the data as it travels between your computer and the website. They're essential for online banking, shopping, or really any site where you log in. Kerberos. It's an authentication protocol, mainly used in enterprise networks and Windows domains. Instead of sending your password every time, it issues you an encrypted ticket that proves who you are. That way, once you log in, you can access multiple services securely without re-entering your password. Kind of like having a VIP pass that gets checked automatically. RDP, Remote Desktop Protocol. It lets you control a computer from another location, as if you were sitting in front of it. Great for IT support, but dangerous if left exposed online. MQTT. It's a lightweight protocol for IoT devices, letting them send small messages efficiently. It's popular in smart homes, but often lacks strong security. Modbus. It's used in industrial systems like factories and power grids. Because it's old and unencrypted, it's a major security risk if left exposed. And that's a whirlwind tour of the most important networking protocols. Each one plays a role in moving data across the internet, from browsing websites and sending email to controlling smart devices and running power plants. Remember, understanding these isn't just about acronyms. It's about knowing where data flows and where attackers might slip in. Subscribe for more tech breakdowns and let me know in the comments which protocol you'd like me to dive deeper into next.